Hello everyone. So this session is about a simulation game that I have created using vibe coding. So this is about decision theory, teaching decision theory. There are different options that we have. So the way this works out is I have created different logins for students or participants and for instructor. So like you see here, so basically the objective is to have an interactive operations management simulation where teams apply decision theory concepts which are different for each round to make production, inventory, and supplier decisions under uncertainty. So as a student or participant, you have to create a team and then join a team. And then there are 5 rounds. As I said earlier, round one uses expected utility theory. You need to calculate expected values and take your decision accordingly. Second round is about prospect theory, overcome loss aversion. Third is about Bayesian updating, update probabilities with new data. Fourth is multi-criteria decision analysis, weighted scoring. And fifth is bounded rationality, satisficing versus optimization. So there are different theories which are being used. And if the student understands the theory and applies it, the results would be better as compared to other decisions. And there will be a comparison between different teams. And you can also play this individually. So you have to make decisions by reading the theory and scenario context. You need to analyze your team specific numbers, set your production quantities, overtime, and outsourcing levels. So we are saying you can produce the quantities on your own, or you could have overtime given, extra time to the people who are working on the production, and you could also outsource. And you will be given a range, a forecast range, and based on that, you need to decide. And results will be, you will be shown profits, service levels, emissions, and reputation. And you can compare a performance against other teams and learn from each round's outcome. Another important thing in this is the challenges. Each team receives unique numbers for the same scenario. You can't copy another team's answer. You must understand the theory and apply it correctly to your specific situation. And this is a prototype. You can always change that. Another important thing that I want to show you is, for an example, if we are talking about round one, we have expected utility theory as the basis given by von Neumann and Morgenstern, 1944. So what is the winning logic? Calculate expected value for each option, which is probability into payoff. High volume option, probability high into payoff high, plus probability low into payoff low. Then teams can take, or individuals can take, a conservative option. EV is guaranteed payoff, no uncertainty. So winning logic, winner must choose the option with higher EV. And the example calculation is given here. So the key insight that we want to drive is, don't be intimidated by uncertainty. If the math says high risk has better EV, take it for this, and there will be some learning. Now let's move on to the simulation game itself. So I'll only discuss round one as of now. Otherwise, it will be a very long video. And this is the home screen of the game. So I'm calling it Adaptive Operations Lab. Scenario Adaptive Operations Lab is make production, outsourcing, and priority calls under uncertainty. Each round draws demand and throws disruption, aim for profit, service, and reputation. So I have created some signups. Okay, so this is the first student sign up or participant sign up, test underscore 5678. And I can log in using this. It is logged in. So I can give a team name. Let's say I give the team name as new. Then I create team. I have a code to join here. So I put the code T4N3 and I say join team. So I'm part of this team. Round number one, you can load the current round. When I code the when I load the current round, I have the expected utility theory. Choose the option with the highest expected utility by computing probability into utility for each outcome. So I've given the theory here. Supplier has 60% chance of delivering on time, 40% chance of 2-week delay. High volume production yields 8,000 profit. If demand is high, 45% chance, 2,500 if low. So here you see there's a 55% chance of demand being low. So you have to make your decision accordingly. Conservative production yields 4,000 profit regardless of demand. That's the conservative production. Calculate expected value. to determine optimal strategy. And this is a snapshot. The forecast range for SKU A is 450 to 650. For SKU B is 250 to 380. Capacity total is 900. Service targets are 95% and 90%. And the costs are also given. Accordingly, you can decide. Now, I also give some more points, data points, how to decide. And here we can have the decisions. Okay. So SKU A, let's put it 500. And I say that I will have 20 units outsourced. And I will produce, let's say, 300 SKU B and 300 SKUs of B. I will outsource only 10. Then I will also employ some overtime hours, let's say 10. Then I can also decide the allocation priority. Right now, I have SKU A is the first priority, SKU B is the second priority. And then if I submit, then I can submit my decision. Decision submitted. And for this team, the profit is 7224, 92% service, emissions 947, reputation 53. And there are calculations for all this. So this is for the team. Now, and this is the trend for various rounds. Right now, we only have one round. You can see the variations over different rounds. Now I move on to the instructor login. So if I go to the instructor login, I should be able to see the result. So right now there's only one participant, but still I'll show you how the output looks like. So I will log in as an instructor. I log in. When I log in, I will need to refresh the data. When I refresh the data, so for me, this team is new, right? Team new, team result. And right now we have only one. So winner profit is 7224, service level is 92%, 947 is emissions. So their performance is 36% above average profit. Now, this average is calculated for the earlier attempts that I made as participant. So right now we have only one team and one individual participating. Over a period of time, it is 36% better. And P1 800 units produced and so on, 500 plus 300 and so on. Overall leaderboard, this is cumulative. Right now, we are not bothered about that, but you can see the results. Yeah. And you can also download the logs. So now this can be modified, but if you are having multiple teams, you can see which team is the winner. And then for each round, you have a different theory to follow, and you can modify your decisions accordingly. So I'll stop here. I hope you like the video, and I will make more changes and I will post more videos. Thank you very much.